In this video, I will show how to find the area of the surface generated by rotating a piece of the graph around a horizontal or vertical axis on a given interval. And because we're rotating around the y-axis, the formula that we're going to use for finding the surface area is the following. It's going to be the integral of 2 pi x ds, and ds, depending on the circumstances, can be interpreted as either square root of 1 plus f prime x squared dx, or as 1 plus g prime y squared dy. And if we're going to interpret ds this way, then x in this integral will remain as x, and the limits will be from a to b with respect to x. However, if we choose to interpret ds this way, then we would have to change x to g of y, and then write the limits of integration from c to d with respect to y. And the choice really depends on what's given and how the function is presented. In our case, the function is given to us as a function of x, and the limits are given for x, meaning the choice is obvious. We're going to interpret ds this way. So the formula that we'll be using is the integral from a to b with respect to x. Here I leave x as x, and instead of ds I write the square root of 1 plus f prime x squared dx. So in order for me to find the surface area, I have to evaluate this integral for a given function f. To set up this integral, I have to find the derivative of the function, which is x squared over 2 minus 1 over 2x squared. The square of this will be x to the 4 over 4 minus 1/2 plus 1/4 x to the 4. Adding 1 to this will have the following effect. Negative 1/2 will just become positive 1/2. And since that was the only change, we now have a perfect square of the sum of these two terms. That means after we take the square root of this, we'll end up with the absolute value of x squared over 2 plus 1 over 2x squared. But since this entire expression is always positive, there is no need for the absolute value notation. And now we are ready to set up the integral. We're going to have an integral from 1 to 2 of 2 pi x, and that entire square root is now x squared over 2 plus 1 over 2x squared, and all that is with respect to dx. And the rest is just figuring out what the integral is. So 2 pi can be factored out, x can be distributed, so we have integral from 1 to 2 of x cubed over 2 plus 1 over 2x with respect to x, and the derivative of this will be x to the 4 over 8 plus 1/2 ln x from 1 to 2. Plugging in 2 will give us 2 to the 4 over 8 plus 1/2 ln 2, and plugging in 1 will give us 1 to the 4 over 8 plus 1/2 ln 1, which is 0. And simplifying everything will give us 2 to the 4 is 16. 16 minus 1 is 15 over 8. and we have plus 1/2 ln 2. So distributing 2 pi will give us 15 pi over 4 plus pi ln 2, and that's the area of the surface obtained by rotating the piece of a given function on a given interval.